Login acceptance.
When I look back at that point in time when I was in school, like back at university, I learned how to program. I learned how to program Java. I learned how to program many other languages, like even obscure languages like some assembly, Pascal, Basic. But one of the things we focused on was creating features, creating a bunch of features that would help the industry. However, looking back at nowadays, what the main threat is, we didn't learn much about security. It was just making sure that it works, making sure that you apply patterns, making sure that it is efficient. And still nowadays, I see that a lot of people don't have that focus as a developer on security. So I am happy that, even though the room is not filled, but that you're all here at this point in time. 4 o'clock normally in my book is beer o'clock, and you're here for a security talk. However, maybe you have done some, oh, that is way too much. Maybe you've ever seen this picture before. Who has seen this? Who knows the reference of this? Come on, who knows that? I know it's a children's book and a children's movie, but it's, of course, the infamous Harry Potter. This is a picture from King's Cross Station in London. And it symbolized that platform 9 3/4 where Harry has to go to get to, how's it called, Hogwarts, or whatever that castle may be. The point is that 9 3/4 is not a thing. However, if you know how to put the right pressure with the right tooling on the right spot between platform 9 and platform 10, and you run in that wall with the right amount of force, ta-da, you are there at platform 9 3/4. Unfortunately, the same happens to software. If I know where to put the right force with the right tooling, with the right pressure at the right endpoint or the right piece of code, I can get into stuff that you didn't think about, because we, again, focus on features, not so much on getting people out. We try to enable people, not so much keeping people away. However, it is something that we need to do. This is me. I'm Brian. I live in the Netherlands. I'm a Java champion, do a bunch of stuff in the community, like leading jugs, whatever that may be. And, well, that's my Twitter handle. We asked a bunch of people, and that this is part of our state of open source security research that we do at Snyk every single year. And we ask people like, who is responsible for security? Who do you think is responsible? Is it like just hands? Do you think that it is purely something for the security team? A bunch. I get that. I mean, I'm a developer. I just want to build. Who thinks it's the operations folks? Nobody. Who think it's nobody's responsibility? I'm with you. Don't care about it. If somebody gets in, perfectly fine. No, the point is that we asked to a bunch of people, and let's see like developers stand out, but see that it is a collaborative thing between developers, security, and operations. And we all know what DevOps is, right? Developers and operations, tearing down walls, getting them together in a team, and hallelujah, we're better, faster, and stronger. Unfortunately, security is still a siloed thing at the end. And people are not so much looking into security, but just building stuff, and afterwards like, hey, security dude, come over here, let's look at my code. And they come up with this big audit trail or this big report like, you're doing so much things wrong. And that's when we get into a fight. Well, maybe not that much, but that you got friction. However, a lot of people believe that developers should take their fair share. And that's for a reason, because we create code. We make the decisions what to use, how to use it, what kind of code constructions we want to use, and how to solve things. Only we are there with that mind again to create features. And that program manager is breathing down my neck and saying, I want that feature today. We all know that, right? Who has such a program manager? I had two. The rest of you was, oh, you're quite lucky, just a few of you. So let's point at a few security best practices that you might have heard of. And if you, at the end of this talk, you say like, hey, everything you named out, I already knew, good for you. Then you just know you can check that box. I am quite aware of things. On the other hand, you should look at this as well from the other side. Who of you does code reviews in their code base? Excellent. Who of you pushes that code review at the end of the sprint, say 3-week sprint, we've got 1 day to go. Hey, junior, can you review my new feature? Make sure it's done in 20 minutes because we need to demo it. Who recognized himself in that? Some people are like, eh. But is that fair? And then in code reviews, we look at features, or it's like bashing each other, like, no, that bracket should be on the next line, not on the same line. But fair point is we look at the code, is we see if the quality of the code is good, because we all care about quality. But how many of you look at the code and look for security vulnerabilities? A bunch of you. Thank you. I appreciate that. So take this with you and take this as pointers to either write your code in a good way, also know what you're doing, but also take this with you to your team so that they have pointers to look at when they do a code review. And again, you can still say to that junior, do it in 20 minutes, and also look at the security features. Good luck. Bye. First one, SQL. Yeah, there we go again, SQL injection. Absolutely. Absolutely. And there's a reason for this. It's still A1 in the OWASP top 10. And I know the OWASP top 10 is there from 2017. Okay. But it's not only SQL injection, it's also NoSQL injection. Because NoSQL injection is kind of like SQL. They put in a language that pretty much looks like SQL, and you can do pretty much the same thing to NoSQL databases. So actually, NoSQL is still SQL. Well, let me get into actual code right away. I will run an application. I will first show you for those who is not familiar with SQL injection. Who knows what SQL injection is? Almost everybody. Good. Still, I'm gonna show you. For those who are like, yes, I have no clue. Yes, I'm gonna show you. Don't worry. Just put your hands up. It's okay. So what I'm going to do is I'm going to go to my application, and this application contains people. People with a nickname or with a username, a first name and a last name, and I can search. For instance, I can search for Spider-Man. Yay, works. However, it says you can search on username. But what I can do as well, I can just try to do something different. Now I just try to break out of the query, and instead of only looking at the username, I'm looking at the first name. And hallelujah, that works. Okay, so what? Now, let's do this. What I'm doing here is, with the semicolon in, we'll say the second character, I break off the initial query. The initial query is a select query. I break it off, and I just start a new one, because that is possible in SQL. A lot of people were like, is that possible? Yes, by default, this is possible. So I update every user and set the name to Mohaha, because I am so freaking funny. So you see no search results, but if I look over here, you see that everybody now had names Mohaha. Okay, fair point. You made your point, Brian. SQL injection. Let's look into the code. So what I do in my repository, I do it the old-fashioned way. And people say, but we now have Spring Data. Let's use that. We'll come there in a second. So let me enlarge this. What I'm doing is I've got a parameter, and this parameter I put right away into my SQL string. And because I make this part of my SQL string, I can break out of that SQL string, compile a new SQL string, and send that new SQL string up to the database. Who knows what the right conclusion is to change this? What would you do? Just scream. Parameterization. Almost. Prepare statements. That is the actual end words, but it's the combination of prepared statements with parameterized queries. And there's a reason for that. And again, people will say, but I'm using the CRUD repos from Spring Data. That will save me, to some extent, again. So just to make this quickly, instead of doing this, I am putting a question mark in there, and instead of a statement, I prepare a statement. Prepare a statement with the query I am using. OK, cool. But a prepared statement, and it is not a statement anymore, this is a prepare statement. Fair. Next thing I need to do is I need to insert that parameter somewhere. So again, I use the statement, and I set the string item1 parameter. Cool. Now I can move this away. OK. What am I actually doing here? You're parameterizing your queries, people would say. Yes and no. A prepared statement works in a different way. A prepared statement is actually a two-way execution. By preparing a statement with the query and these wildcards in it, I send it already to the database management system. In this case, a very quirky H2 database, but it doesn't matter. I send it to the DBMS. And the database already takes care of the execution plan. So it already compiles the execution plan, and then in a second go, I insert the parameters. That way, because the execution plan is already there, it is virtually, I wouldn't say super impossible, but virtually impossible to do SQL injection. Because what we try to do with SQL injection is to turn that execution path of the query around. So some people say, OK, what is the actual query that you're sending to the database now? None. I'm sending a prepared statement, and I'm sending parameters in 2 goes. So there is no way of doing a single query. There is no query that I sent. I'm to let the database take care of this. So of course, I can show you now, like by rerunning this, that this actually works. But there is a big difference with, for instance, the CRUD repos that you can extend in Spring Boot. A lot of you who use Spring Boot or Spring Data, let me just put it there. Yeah, you know that you can just extend the CRUD repository, and then you have the basic CRUD repo, the basic CRUD functionality, you have that for you, right? Like saving, updating, that kind of stuff. What happens is, under the hood, probably it uses JPA and Hibernate or something like that, and it creates the query on the client side. So still, as long as you're staying in that metaphor that you're just using these pre-generated stuff from Spring, you're all good. The point is when you are creating your own queries, because that is also possible, then you still have to be looking into SQL injection. Why? It creates the full SQL string on the client side and sends the full SQL string, so the execution plan is not yet there, to the database. And then in one go, the database, execution plan, and executing it. So there is a difference. I wouldn't say don't go there, period, but technically the prepared statement from a security point of view is way safer than doing that on the client side. Who uses Node.js or JavaScript or like these kind of things? If you do that with a lot of NPM libraries, they do the same. They do client-side escaping. And that is good to some extent, but it's not the same as a prepared statement. So there is a difference technically, but as long as you're using the CRUD repo and just doing that thing that it's actually used for and not doing specific queries, you're good to go. All right, just to show you that it actually works, going here, doing the same query, doesn't give me anything, and they're still there. Woo, solved it. So look at it from the way, it's not just parameterization, because parameterization and client-side escaping can still get you into trouble if you're doing it the wrong way. It is not just prepared statement, because if I do a prepared statement with a full query, I still have the same issue. Prepared statements with parameterized queries. Yes, that is a whole lot of thing for just a simple SQL injection query. Cool. Let's go to the next one, because I've got a couple of examples that might look obvious, but I want you to know what you're actually doing. So we did this SQL. Cool. Next one. Sensitive data. One thing that we try to prevent is that you probably work with clients. Who works with clients and client data in their enterprise software? I do. And we don't want to be that next thing that goes out in public like, hey, you lost all your client data up in the streets, and everybody can read what the phone numbers of your clients are and what the email addresses are and the credit card numbers. That's not what we want. So we have to take care of sensitive data. We have to make sure that we practice the least privilege principle. So that means also that when outputting data, we have to be sure that it doesn't output too much. Even though, say I have a JSON endpoint, and a JSON endpoint needs to expose data, even though it uses just 3 of the 5 parameters, that's not good. Then you should only give these 3 values that you need to do. So let's go into code again. Say I am having an API, right? I'm enlarging. Oh, that's not good. I am enlarging this thing, and what I do is basically I search for all users in my application, and I show the domain value. So it's something like this. You see. But as you can see, you don't want to just show this because, first of all, you shouldn't be doing this, like the password as pretext, but we come to that later. But I don't want to output this. So one thing that you shouldn't be doing, first of all, is just outputting your domain entity because it's easy. Now, the first thing that you normally should do is make sure that for every endpoint, you make a specific data transfer object that only contains the values that you need. So for instance, if I want to say I only want to export the first name, the last name, and the username, and I want to keep the password and the comments for myself, don't put out the whole data entity that is the connection to your database. No, make a specific output object that does this. So instead of outputting all users, I created an API user for this API endpoint. And this API endpoint just takes the first name, last name, and username. So separate these concerns. That's one thing. OK, fair point. And you believe me if I show you that I'm outputting API users, that you're just getting the 3 values, right? But say you don't want that. Why not? But still. There are some nice things that still, even if you have entities that you want to push outwards, and this is a Spring Boot application, and I'm using the Jackson parser to do this, I can do a bunch of funny stuff. For instance, this is my entity, and I just want to use my entity, and what I don't want is that my password and my comments are outputted into my API. One thing what you can do is, and hopefully you know this, is by simply ignoring this in my JSON output. And if I do this, this will not be outputted anymore, this will not be marshaled into JSON, and we're done. Kind of. So rerunning this will not show the comments and the password anymore. Yada yada, startup, come on, you can do this. Good laptop. So again, I now solved that problem. But wait, there's more. I now sound like that Telso thing, I know, but still. One thing I still have is that I output my users in my log files. And again, might not be what you want. We're living in Europe, so we have to deal with GDPR. That also means that if you're outputting user-sensitive data, PII data, private identifiable information, in your log files, you're basically having a data leak. Because does the operator need to know what the actual password or the credit card number is for that specific user? Maybe not. So you should be aware of this as well. And it's very easy to say, like, OK, this domain entity, just print it, and I know it, and it's good. But if somebody gets access to the log files, that means that he has access to every single user that did something in your database. One of the things you can do, of course, is making sure that the output of these entities are restricted. And you see, I'm a very lazy developer, and I'm using Lombok over here. Who hates Lombok? Good, now we have records. Perfect. Done. Just use Java 17 or 16 records. Cool. But within Lombok, I can just override the toString method. But again, I said I'm lazy, so I can do something like toString.exclude. And now the comments, for instance, are not there in my log output anymore because I messed with the toString data. If you're using records, the toString is also automatically generated, and then you have to overwrite the toString. But be aware of that in these entities that contain specific data, like credit card numbers, first of all, I hope you hashed it. We come back to that later. But if you don't want that data into your logs, be aware that the toStrings and the logs are also cleaned out of this. And with some easy things that you might not have think of in one go because you're focusing on these features again, you might forget. And that is what happens a lot of times. People get audited, and then well, I won't say you're screwed, but you're at least get like that tap on their fingers, like, don't do that again. So by doing this, rerunning this, we will see that the comments are not anymore available in our log files, or in this case, in my console. Does it still make sense? People sleep? Cool. But we see over here that there are no just first name, last name, username, and password. Okay, I shouldn't be using the password, but you get my point. Get into your domain entities, see what you want to print out. You don't need anything, and you don't need everything. Okay, so yeah, we have that, cool. I will output the slide so you can watch this all back. Dependencies. Who was there in my previous presentation this morning? A couple of you, so you might recognize a few of the things I'm going to say. If you know the answer, it's just one of the many things. Then you have seen this graph. I used it. For the rest of you, if this is the thing that you put into production, how much of the jar, the war, is actually the code you wrote? What do you think? It's about this. It's not that much. And we said we did code reviews, but a bunch of you just pushed it over to your juniors and say, do it in 20 minutes. I took 3 weeks to build this marvelous feature. You do this in 20 minutes, and fine. But the rest of the code is all the code that you include, that you inherit, that you got from Maven Central or other repositories. And if things go wrong, you're not just responsible for that tiny little dot. No, you're responsible for the whole shebang. Or not. Who is not responsible for that? Good for you. I want to have your job. So this is a Spring Serverless application we wrote, and it was 222 lines of code, very bad. I wrote it, a lot of duplication, it was demo code, just to give you an example. It had 5 dependencies, 5 direct dependencies. But as you know, dependencies pull in dependencies, pull in dependencies, pull in dependencies several layers deep. 54 dependencies in total. And now the million-dollar question. How many lines of code did I put into production? What do you think? A couple of thousand. What is a couple of thousand? Is that 5,000? Is that 10,000? Sorry. Almost 500,000 lines of code. Because if you look at the dependencies, it says Spring Framework data and some AWS stuff. So these are large packages, including several layers deep of problems. And I'm responsible for not the 222 lines I wrote, and my junior just looked at and say, it's okay. But I'm responsible for the almost 500,000 lines of code. So as we know, attackers are targeting open source because, hey, if there is a framework that is used heavily inside the community, I have a pinpoint where I can go, and I have a potential of a lot of victims that I can look at. So we need to take care of that. So let's make sure this one is off, and let's go into another application. And this application is, again, a Spring Boot application, and this Spring Boot application uses, it's basically a grocery list. So if I enlarge this, you will see it's beans for 50 cents, milk for $1.09, bread for one. These were pre-pandemic prices, I see. However, again, the data is not as important as well. If we look at this, then we see it's 3 fields and a bunch of getters and setters. However, this one is interesting. I'm using the Spring data thing. And it's not like we know that the CRUD repository gives you all sorts of things like the find by name and the find all, and that's pretty cool. But because I'm using Spring data REST, I can do this annotation and transform my CRUD repository into a REST endpoint. Pretty cool. Now it works. Ship it, done, never look back. So let's run this. OK, it runs. Hopefully, yes. And let's go back to, it's also at 8080. Maybe I should do this on different, no. Yes, this is my hell browser. This is just something so I can show you what's happening. For instance, I can do /items/1, and I will have the first item in my grocery list. All cool. You get it. If I do 2, I get the second one. I also can do things like find by name, and name is beer. And that is basically the CRUD repository transformed into the REST repository. And hey, I've got beer. Cool. Ship it. But wait, there is more. This is an outdated version of Spring Boot. And what I can do, I can do a CRUD, what is it? An update request with curl, a curl update request, and give it a specific header. And this is the header. Well, it's not the header, it's actually the body. Because what I can do, if I do an update request, I can send it a JSON body. And as you can see, this is legitimate JSON. Only, it's kind of weird what's in there. Spring has an expression language, SPEL, Spring Expression Language. And we can interfere with what's there in memory. And I can, for instance, call, what should I call? The runtime. And I can execute a command. So let's do that. Just do that. What I'm going to do is I'm going to look into the passwd file. So I'm doing a curl patch request using just a normal content type, but this body, and instead of command, it's now etc/passwd over here. And what the interesting part is, I just launch it on item/1, which was there because of Spring Data REST to show me my first item in my grocery list. If I do this, you see that over here, this is the content of my passwd file. But if I can call my passwd file, I can call any other file. I can also call any command that is available to me depending on what kind of privileges the user has on this system. And again, I didn't test for this. My feature tests were great. My integration tests were great. But I'm using an outdated version of Spring Boot or Spring Data REST. And if I scan this, I find out that there's an arbitrary code execution. And if I would, and yes, I blew this up, like I enlarged this, but let's go upstairs. And if I would here, I use Spring Data REST 155 build snapshot. Don't use snapshots. But if I would update to 159, then it would be interesting enough that all of my problems were gone. Well, a bunch of other problems as well. So you should take care of this as well while you're coding, but also before you release to production. Cool. Next one. What's up next? Input. Cool. Cross-site scripting. Well, basically there are 2 ways of doing cross-site scripting. Well, rule 0 for preventing cross-site scripting is never insert untrusted data except in allowed locations. Okay, that is very, very vague. So basically what we say is sanitize everything. Make sure that everything that comes in is checked before it just reaches the service. And there are 2 ways, basically there are 2 ways to do cross-site scripting. There's reflective XSS and stored XSS. Does anybody of you know what the difference is? Just raise your hands. 1, 2, 3, 4, so a handful. Well, basically it burns down to this: non-persistent and persistent. Non-persistent wants to say like, okay, I am giving this piece of JavaScript as part of the URL, and I know that this piece of JavaScript will be executed right away in the browser. It's non-persistent. I need to provide, as an attacker, I need to provide that script as part of that URL. I may obfuscate it with a URL shortener, but it's there only basically on the front end. Persistent URL is the other way around. I basically not attack your application, I attack your database or your persistent storage. And if I can insert a script over there, I know that when it loads, everybody that's looking for it is infected with that cross-site scripting. And it can be as simple as just an alert, which does nothing, but I can also like send your session ID to another server, and I can hijack that server. 2 examples. Need to quit this one. Need to start up the other one again. So the point of that scripting is that we want to execute code that we provide, and we want the next visitor to be infected, that code executes over there. So going again to my local host, and I search, and I find Batman. What you see over here in my you see that I give a parameter Batman here, right? And that parameter is basically executed right away. So if I not give Batman, but I do this, is there. Because what happens is, I will do this again. What happens is, I take the parameter, and I print the parameter right away over here in my, well, H1 header, what it is. If I don't sanitize this, and I will just show you the code, then things can go horribly wrong like this. And now I'm just alerting something, but I can also call a script on another server, insert that, or some sort of other things. Let me see where I have this. I think it's in the user controller. Yes. So if I enlarge this, you will see that the parameter is part of the request, and without sanitizing it, I literally write it right away to the response writer. You shouldn't be doing this, of course. One thing you can do is sanitize this, and there are a few things to do. You can use the string utils, the strings. What is it? String util. String escape utils, which is part of the of Apache text nowadays. And the other one that I like you to meet is the encode library from OWASP. And if I do encode library, there are a lot of encoders. And in this case, I want to encode it for HTML. And I say, hey, encode for HTML, put the parameter around this, and execute it again. So if I do this, the parameter will not be pointed right away. But if it is a piece of JavaScript, it will be encoded for HTML, and it will be just, yeah, it will be nonsense in your screen, but at least nobody will get harmed. So doing the script thing again, you see that we now output this. Well, it still doesn't make sense, but at least it's safe. The other thing is far more important. What I can do over here is say, look at your database. And is your database actually the only thing that is used by your application? If that thing is yes, hey, fair enough. If that thing is no, then you should be also looking at what comes in from your database, and you're displaying it right away. For instance, if I am inserting, like in this application, in this demo application, over here, I am inserting all my users over here. But if I insert a new user at the beginning, and that new user has a comment, and that comment is, again, that alert 1, which is nothing special, but now everybody who has this, who visits that search page, will be infected by that script that is executed. So take a look at these scripts as well when they are executed, if they are actually customer-facing or outward-facing. So going to the search right away, it will already give me the alert because the last user in my file, in my thing over here, doesn't have a comment. The comment was a script that was already executed before the rest. So now I'm displaying this, and what I can do, for instance, is go to the user that I want to show and make a sanitization filter in the same way so that whatever I execute is always safe. Again, if you're using a source from somebody else, say JSON input from an API, if you're using if you're using a database that is not completely and fully in your control, like another application can also insert in that, be aware that you should be careful with this data and also sanitize it before you push it out to any of your users. XML parsers. Who still uses XML? A few. Well, XML parsers by default in Java are vulnerable. And if you don't know, I will show you. So, yes, cool. We've got XSS, fine. I can import XML over here, and I can choose a file. Now let's go into the files already. It is somewhere, no, I don't need this. In the examples, if I'm just using a normal user file, it would look something like this. I can include a user like with a first name, last name, username, and I parse it out, and it's a new user. Fine, perfect. But what I can do as well, I can insert a bad way of XML. And this one is a bad way. This is what we call an external entity injection. What am I doing here? I am using a doc type with an external entity. And in this case, this external entity points to my passwd file on the system, or to a file on that system. And the doc type and the external entities are there normally to do DTD checking, or use DTDs, external DTDs to validate your XML. But because I bind this entity to XXE, I can use it in my XML. So this means that instead of a comment over here, I now output what's in my passwd file, which is basically outside of the scope of my system. Zoo. Java Code Workshop examples, yes. Users, bad, very bad. So I open this one, and I submit it. Hey, this doesn't work. Maybe I already fixed it. That will be great. Password, username. Oh, it's not. Oh, I get it. It's not outputting the comment at all. The point is that this is possible, and you should be aware that if you want to fix it, I'm not going to show you because it takes way too long, and I only got 12 minutes left. If you want to fix it, you need to set a few entities, you need to set a few settings in your XML file. One of the things is if you go to your XML parser, and I'm using the sex parser over here, but it doesn't matter what parser you use. Basically, all parsers in Java that are there available for you are harmful or have this exploit in there. And well, basically, the sex parser doesn't do a lot, but what we can do is set a feature on it, for instance, on the factory. And I will enlarge this 1 second. So what I need to do is to make sure that I disallow external entities for this factory. And because I set it on the factory, every parser that will be created by this factory doesn't have this property on. But by default, this property is true. So by default, I am allowed to insert external entities and basically get some data from somewhere else in your system and output it like I actually wanted to show you. Be aware of this. And yes, this is a known issue, and nobody's basically fixing it. So by setting this, it is one thing to make sure that if you're using XML parsers, that you're safe. Right. Java serialization, or the gift that keeps on giving. Well, For those who don't know Java serialization, basically you have an object, we translate it into a byte stream, and we can store that byte stream either in a file or we put it over the line to somewhere else. On the other side, we can do deserialization. And with deserialization, you take that byte stream from a file and you turn it back into an object. That is what basic serialization was. But the basic serialization in Java is, well, I would say faulty, but it's bad. This is the way you serialize a thing. You see that I have a value object, and I have a value string and a side effect string. The point with serialization is that when you deserialize an object, they do not use the constructor. It uses a weird way of reflection. And because it uses the weird way of reflection, a few things can happen. Well, I serialized an object. And this is the serialized object on my machine. And it says, hi. However, I can change this. I can just pick this up. It's not encrypted or whatsoever. And I can just change this to hello, which is fine, because you just have another value. But if this value implicit an action, then it's interesting. What happens is, when you deserialize an object, you call the read object. However, the read object is a private method on your machine or on that object that is serializable and can do weird things. For instance, this is what we call a gadget. A gadget, this one overrides the read object, even though it's a private method, and it reads the data. It will get inserted into the values, but it has a side effect. It runs the command. And you're like, yeah, does this happen? Well, it happens more than you think. This is what we call a gadget. Because you deserialize something, you also kick off an action. And that's where the problem is. The point is, it's most of the time not just one thing. It is a chain of gadgets, what we call a gadget chain. And once somebody found a malicious gadget, and can connect a few of these gadgets together, and at the end, there is a gadget that can execute a certain thing. These chains are very, very hard to grasp, to get that. But with the amount of dependencies that you have in your system, it might be the case that you unwillingly have such a chain available. I took this screenshot from Ian Haken, a guy from Netflix, and they launched some stuff on their machines to check what they're doing. And you see that in this case, because they're implementing a set of, like, what is it? 1, 2, 3, 4, 5, 6, 7 libraries, all combined together could end up into arbitrary code execution. So a few of these things are known by, like, if you have commons collections, there is a chain of events in commons collections alone in that library that can lead to arbitrary code execution. However, it can also happen with a combination of libraries, and there is the scary part. So if we have a serialized object like this, you probably think like, okay, if we deserialize, it should have a reference to data, this date holder, or to date. Well, that's not particularly true, because it uses a weird form of reflection. We can also implement a class that extends date. If that is already in the chain because it reuses the references, something totally weird can happen. Again, these chains are very hard to create manually, but once a chain is found and published, then we're on the interesting side. If you want to know about that more, go to things like a tool called Why So Serial. I like the name. And they have a lot of these attack chains that are known, like commons collections, some JBoss problems, some Spring problems, a Wicked problem, and they can create the payload for you and you can test it. Take a look at that tool. It's interesting. But what's up for you? What should you be doing? But what if you need to implement serializable? Well, first of all, I won't say shove serializable on the side. Don't use it. But if you need to do it, override the read object on that object that needs to implement serializable because of whatever chaining you need to do, and make sure it gives an exception. So serializable will not get caught. That is one of the things you can do. if you still want to do serialization, one of the things you can do is use Apache Commons IO that has the validating object input stream. Because that object input stream takes the stuff already, deserializes, and then casts it normally to the object that you want. However, if you use this validating object input stream, it actually inspects the bytecode or the byte stream to see if it's the object that you actually want to deserialize. So in that case, you just block everything that you don't want, which is an option, but again, I would say try not to use this. Encryption and hashing. I go fast on this because one thing is important: don't write your own encryption, unless you are a cryptographer. Don't do it. What you should be doing is you have a low-level encryption because they have capabilities, but use strong vetted libraries that do these encryptions. And one of these things that you can use, well, we have two-way encryption. We know that. Credit cards, we need to get the actual data back. For instance, and we have one-way encryption, hashing for instance, passwords. Again, don't write your own encryption, but look at what the current standards is and what's good enough. For instance, for encryption, you can use Google Think. And Google Think, now it's version 161, is a great job to do the advanced encryption standard, to use that. This is just a code example, but actually you're just setting things up, and you do encrypt and you do decrypt, and that's what you want. Again, ask your security friends in your company what kind of encryption you want to use, what kind of templates you need to use, and just use them. Don't think about this yourself too much, or read it, or ask your security experts to do so, but use these libraries because they are well implemented and well maintained. Large companies are around this. If you want to do hashing, you can use, for instance, the Spring Crypto library. Nowadays, for password hashing, they say you use either Argon2 ID, so that with ID mode, or if that's not available, for instance, bcrypt. And bcrypt and Argon2 ID password encoders are available in Spring Security, which is, or what did I say? Yeah, the Spring Security Crypto, and with the Spring Security Starter, you already have this in place. It automatically salts your password, and because the salt is there, you have to use the encoder to match the password to the string, but in that case, you do it the right way. Currently, it's either what I said, Argon2 ID. If that's not available, bcrypt. If that is not available, then scrypt, but don't do PBKDF2 anymore, or other things like, well, MD5, of course. But use these libraries, and they are there. They are available, and they are well known by a lot of folks, and well worked on. Last one. I got 2 minutes and 20 seconds left. Logging. Well, I don't know if you've ever been in that situation where you had a data breach. Whoever had a data breach? I had for once. And you know what happened? We fixed it in 5 minutes. That JSON ignore thing, that was the case. We outputted an ID to something, and combining that with another endpoint, you could get other data, and another data, and that combined was PAI data leak. Whatever. These were the questions that people were asking me. My management was asking me, all the people that would say, like, we need to focus on features, and security is implicit. But then you get the aftermath. How was I exposed? How long did it take? What kind of data is leaked? And am I a victim? We couldn't answer that because we didn't have the right amount of logging in place. So what should you do? Log everything. And what I mean with everything is every incoming request and every outgoing request. Of course, make sure that your data is not containing PII data, but that you know which IP address is coming in and what you send outside. Then you have some place to trace it. Also make sure that you centralize that logging, and not only centralize that, and have active alerting on that. For instance, say you're having an internal server and an external IP is pinging that, is doing a request. That's weird. If somebody is trying to change an admin password, that is weird. If somebody is trying to make a request that has the word union in it, that is weird. Like all these kind of things, and there are a list of these things you can actively alert yourself on. If somebody is in, you noticed, you can shut it down and you're not getting any worse. But having centralized logging for your aftermath and for your active alerting is something that is critical. Don't forget about that. If you want to know more, 25 seconds left. We created a cheat sheet with the 10 security best practices, and I didn't call everything that in this presentation, but feel free to look at it. My name is Brian. Everything I showed you from Snyk is free, like the scanning tool. Try it if you want to. And if there are any questions, I have 3 seconds, and I will probably be outside, so come and ask me. Thank you so much for joining.